So, can we build homes like spaceships? Should we do that? And what are the benefits and drawbacks? What about ventilation and makeup air for appliances that exhaust air like hood ranges and some dryers? Join us today as we discuss this idea of a zero air leakage home. And before we get there, a huge thanks to our platinum sponsor, Rheem. They make air source heat pump water heaters that decarbonize our water heating up to 400% efficiency by taking natural heat out of the air, using refrigerant to pump it through, and then exhausting that air back into the space. And just like a tight home, you need that makeup air to make these things work. But you won't have to worry like you might with a natural drafting water heater in a super tight home. These just replace the air right back into the space again. Plus, if the home is tight, it's going to be more well heated, which is what these systems need to operate, is warmer air. And so they have 240 volt systems with all the sort of bells and whistles for the backup electric resistance heat. Otherwise, they have plug and play 120 volt systems that can just plug right in, swap out gas, 120 volt, and you're on your way. Tax credits by the end of this year available, and then IRA homes rebates in many other states that help fund these. So go check them out at greenhomeinstitute.org/REAM HPWH. All right, well, welcome everyone to Zero Air Leakage. Now what? This session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We are a small but mighty team, and today I will be your moderator. My name is Brett Little, and I am the education manager here. Like all of our courses, this one is approved for multiple continuing education units, including the three pillars of green energy, health, and materials in our certified green home professional designation. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. As long as you're here for the entire CEU approved hour, you'll receive your 5-digit FIAS code if you need to report that. And as long as you're here again for that hour, you'll receive your code from ICC if you need that, courtesy of our friends at Energy Smart Institute, who you can check out for all of your radar trainings. So with that, I am excited to welcome back our speaker here, Chris Lomer-Giddens. And Chris, this is your second time on the show. Several years ago, you were on
Yeah,
again before. So it's great to have you back, and welcome, and please take it away.
likewise. Well, thank you, Brett. And boy, thanks everybody for jumping in on the conversation. This is one that's been piquing a lot of interest lately. We've had some social media comment battles on this thing, and this whole subject of air tightness and does a house need to breathe and all of that. It's definitely an ongoing conversation, and there's a lot of um, there's a lot of education, lot to learn about this. And what we're going to talk about today is what we know and what we're doing about it here. So please put in your questions in the chat. We want to make this a conversation, and Brett will ask them if they are relevant. So thank you, Brett. I'm Chris, my wife, and the boss is Jody Lomer-Giddens. She started LG Squared in about 2006, and we have evolved into a company now that we are architects still. We do interior design. We do our mechanical design. I spent a couple years working with Allison Bales at Energy Vanguard here in Atlanta. I did all the HVAC design there. We kind of took that over here to LG Squared. We do our structural design. We are building science consultants and experts, and we consult with architects, builders, homeowners, anyone involved in construction with building envelope, mechanical design, anything related to building science, and WUFI models, and which is a way to test for, moisture risk in your walls. We are a certified passive house consultant, so we can get a house certified, but we're building houses that are sort of meet this standard, and we evolved into just take the class. Now I'm certified. So we've done a couple of off-grid projects. We actually spent about 4 years on one in Western North Carolina, completely off-grid. We designed it, built it, and it's still going strong. It's producing a lot more than we expected. So that's wonderful. We also we were former GCs, builders, and we now work as more like an owner's agent for our projects, either locally or throughout the country. And we can help someone build a house from remote. I've done it in Florida, North Carolina. It's just so it's about knowing your climate. Lastly, we have a strategic partnership here with a company called Sawhorse. The owner is Matt Hoots, and they're doing an excellent job right now executing our design details, and it's because of their efforts that we got to this zero where we are today. So this is the project is it's a 4,000 square foot home in Atlanta. It's on a 1.2 acre lot, 2 stories, as you see, and we're going to get into chasing this zero and what do we do now that our house is completely tight. We'll address some of the questions about once you're tight, about makeup air, about ventilation, about makeup air and fresh air ventilation and all that. So understanding air tightness is something it is still a big unknown for a lot of people. How do we achieve this perfect envelope that we're talking here today? Then how do we execute that? And that's the job of the GC and with our assistants, makeup air strategies for this super tight, and also our fresh air ventilation, so that we're controlling, we have the amount of fresh air that we need inside a house this size and with this number of people. So I like a little quiz here, and Brett, I would love to hear from you if you don't mind stepping in for a second and answering the question, is it BS or is it BS? Can a house be too tight? Brett?
Yeah, I thank you. I think the answer is flipped. My opinion is that can a can a house be too leaky? I think that's the real.
Yeah. Yeah. Okay. Good. That's a good question. And we are dealing, I think, and of course, I believe, yes, that it can be. I think what we're dealing with now, we'll get into here. I'll talk a little bit about the history, or just a quick minute on the history of air sealing, because it's interesting how we got to where we are today. Corbett Lunsford from the Building Performance Workshop, that says Home Performance, but it's Building Performance Workshop. He did the blower door testing for the house. And I just want to play a little clip here, because this is the kind of this is what we are facing as we get closer to this zero. And I'll explain why we want zero, but for now, I just want to kind of give some backup. Here's Corbett.
Weirdest blower door test I've ever done. I'm with this maniac. This is Chris Lomergittens, who is perpetually trying to chase zero. I punked him at the very beginning, and we got zero because I didn't have my hose plugged in. But he was very excited for a moment. He's still excited because we're at 20. When it settles down, we'll actually be at about 20 CFM 50. One ACH 50 would have been 950 CFM 50. Passive House would have been 557 CFM 50. This is at 21. That's 0.02 ACH 50. And that's a joke. That nobody should be having to chase that stuff, but Chris insists. Matthew, project manager at Sawhorse Design Build, is chasing this thing. What's really funny is the baseline on this is positive 20 pascals.
All right,
I've never seen
this hard for 2 days now, and I'm pretty sure that the wind was not what was doing it. The sun was shining.
So a couple of things that are interesting here. One, he's the one that sort of tagged me as the one to chase zero, that I am a maniac, and I am kind of, and I have mentors of mine who tell me, stop overthinking. And but hopefully by the end of this, you'll see what is my purpose. But what Corbett is doing here is saying, look, we don't need to go to that extent. And that 0.18, by the way, that he's talking about is most of it's coming through the blower door frame because we literally had zero leakage. So it is a different one. It is a different, you know, even performance testers like Corbett, who've been doing this for years and all over the country, he's out there saying, I've never seen this before. He didn't know what that pressure was about. Never seen it. So this house, by the way, and saw in the photos before, we tested this test that he's doing now is without any of the windows cut out and nothing else penetrating the building. So yes, it's a little simpler to get to that without any penetrations. But we've done a project up in nearby here, started at 0.045 ACH 50 at this stage, and our end result was 0.4 ACH 50. So it's possible to achieve that that level even after all the penetration. So this is the project. It's a Craftsman style, and you saw the previous photos where there's no overhangs. I'm going to show you how we get the overhangs on this. Some of you might know it as monopoly framing. It's a very popular term, starting to be popularized because of Matt Reisinger. If you don't, check out the build show, a lot of great information there. So Matt Reisinger was here. He's doing some filming on this project. We'll have a video out next year on his channel, on the build show. But he came by and this video that he posted is now up to about 500,000 views or something like that, or more. You see the number of comments that we have. We're over 600 now. And it was all about this too tight. Is this a mold factory? Is it, a lot of people not understanding what this means and how we can actually have a house with such tightness. And so you get these, interesting comments about it living in a plastic bag. Yeah, I get that. But the plastic bag, if you put a bunch of straws in there and allow for air to move through, it's okay in there. You can breathe, and as long as you filter that air going through the straw, and so you're controlling how much is coming in there, and that's what we're going for here. So there's a lot of this controversy out there about too tight, and are we killing our clients? And no, it's bad for business. Why would we do that? So we'll talk about kind of what we do next soon, but this is just letting you see these comments so you can see what we're dealing with here.
All right, y'all. So monopoly framing in real life.
Just,
check it out. This is the first time I've ever seen a monopoly framed house.
I'm going to talk over Matt, but just explaining how we built the house. And you can see here, no overhangs, no windows. This is our test window, and I'll show you some pictures of that here in a minute. So this is what chasing zero means for me. It's not about that number. I don't care. It's not so much about, hey, I got zero. I'm thinking about the house as, long-term, because all of that air, you're basically bringing outside air in. If you, with leaky houses, even the code belt house, a 5 ACH 50 here in Georgia, even that amount of leakage, you're bringing so much air into the house and exposing all the materials and the people, furniture, everything to outside air. If you think about storing everything outside, like all of your furniture, you wouldn't do that. You wouldn't think about putting nice indoor furniture or finishes outside. So you're inviting all of this in. And so I've seen a lot of, well, we'll get into that later. The sickness, people are healthier in tighter homes because they're not letting pollutants in. We're not wasting energy. We're not wasting all of this energy we spent on heating and cooling the building. We're not letting durability slip. We want to maintain durability forever, so we're not compromising on any on that durability by letting air in. We know with a zero air leakage, we know how much air is coming in and how much is going out. We're not worried about what's happening to our shell and what's happening inside because we know exactly what's happening because we have fresh air systems. And zero regrets. I will always chase this zero because I want to have 100% control over all the air coming in and going out so that I can tell the owner, here's what you can expect. You can have fresh air all the time. And yes, we'll get into what happens when the power goes out. That was another big comment on that post. So I'll do this quickly, but we started insulating our homes back in the early 1900s. Around 1940, it was an architect who said, hey, we need vapor barriers. It got into the code. And then we started, and then that became an issue. And now we started having to look at what is going on now with the vapor barrier. Because before that, we were getting peeling paint from the insulation. The vapor barrier caused even more damage to the interior. You have mold inside the cavities. So they were working on that while there's this oil embargo and concern for energy in the 70s. And then in the 90s, we had Wolfgang Feist from Germany developed the Passive House program, trying to get our buildings to perform better, build tight, ventilate right. The blower door started measuring these things because if you don't know it, if you can't measure it, or if you can't, like it says there, you cannot manage what you cannot measure. And once we measure the leakage, in this case, zero, we're just managing that fresh air that we're bringing in 100% of it. And so this global movement to tight, this is this chasing zero thing. So many people are working towards that, but if you go to Matt Risinger or our channel and find that post, you'll see so many comments about, I don't believe in tightness. I believe we should let houses breathe. Without insulation, sure, they're going to breathe. And I think it's a good idea. But that's old school. Those houses were built at another time with different, expectations. And now we want to be more comfortable. Push a button and be warm, push a button and be cold. Cool, excuse me. So these are the kind of, issues that we find from letting our houses leak. These are primarily water leaks. This lower left corner, this is a project I consulted on. We started off with like a about a $12,000 fix to fix this leak on the lower left corner, caused by a screw that was holding the railing to the wall just right through the stucco. So that little hole where he's pouring that water into is just how it attached to the wall, and it went back. And so water would drain down this wall and right into that hole. And over time, it created all this damage, all the damage that you saw and leaked into the house and everything. That $12,000 fix turned into about a $70,000 fix because of all these other ones like this, just rotting framing. Here I am just peeling away, sheathing like it was just wet paper. So these are the kind of things that we're trying to protect our houses from that get into the structure, into the bones of the house. So if we can keep the air and the water away from everything that we hold dear, our framing, our furniture, our lungs, our skin, everything, then we have more likely that the house will live forever. The people will live longer and they'll be protected and want to protect the house. Okay, so another one real quick here, Brett. Is it BS or BS? Atlanta homeowners spend more money on cooling than heating. Hot Atlanta.
Yeah, I guess I would think so. That would be my initial thought. Yeah, that's
right.
Yeah.
Yeah. So that's exactly the answer, of course, expected. Because we got the Hot Atlanta, that reputation came from downtown Atlanta with all of just the heat island effect we had that. A lot more happened with the Olympics. They were building more, so we had more, hard surface, and it was heating up in downtown Atlanta. So there was this heat island happening more there, and so it got this reputation of Hotlanta. But what I've seen over the years, this is the Atlanta Craftsman Passive House, which is what we're talking about, the zero air leakage. These are the heating loads, and you don't really need to know what all this means exactly, but what you can see is that with zero ACH 50, we're down at the cooling load is higher than the heating load. That doesn't mean we spend more money on cooling. It means our cooling load is higher. At the same time, this house will probably spend more on cooling. If you look down further, you see the heating loads start to become equal as you get closer to like a more leakier house. So the heating load almost doubles and the cooling load goes up, not too bad, 10, not even 10%. So that's not bad. Then you go to 10 ACH 50, but your heating load is now more than double. And so the leakage is what makes us spend more on heating in Atlanta, in North Georgia, than our cooling. It's because our houses are leaky. As we get them tighter, we're controlling all of that heat loss and heat loss, and our loads get smaller and smaller because now we're also insulating more. These numbers, all I did was change the air sealing. This is with the insulation. That's why these square foot per ton numbers are as high as they are. It's because of the insulation and the good windows. If I'd started taking those out, you'd see these numbers on the right drop and the ones on the left go really high. Brett, did you have a?
Well, and Chris, I'm curious what your thoughts are. Of course, if you're looking at sort of climate risk projections in any of the projects you do, of course, obviously we're going to see decreasing, increasing in our heating load, or decreasing heating load and increasing cooling loads. And so is that something you're considering, moving forward as a potential issue to address?
The decreasing loads? Yeah.
Well, no, the increasing of the cooling load versus the
Oh,
decreasing of the heating load, especially in your region, I imagine it's going to be far
yeah.
worse than up north. So,
Yeah, I mean, we have, you see our cooling degree days compared to Duluth, Minnesota. We spend about, 5 times more, in our cooling degree days.
yeah.
For anyone who doesn't understand this real quickly, heating degree days is a measurement based on the amount of time we spend below 65 degrees. And then the cooling degree days is the opposite. It's how much time we spend over 65 degrees in a year. So our numbers are high, much higher than Duluth for the cooling, and then the heating, clearly they're going to spend a lot more on their heating.
Mhm.
So, yes, I think it really it is climate specific. It's house specific as well because what's going on inside, and the cooling loads, they're at the trick is when you start designing for cooling, right? I mean, and that's what we do in warm climate, cooling climates, hot climates. We design our systems for cooling. Well, in many cases here in Georgia, I'm able to size for the heating because it's higher, but I do that with either supplemental heat, which I don't like to use, or we do a heat pump that has variable capacity, variable speed, as long as they're close. We don't want to just totally design for heating. So that's where the trick is it's in these system specifications, designs, and capacity. So this one, this might be this is great because both the loads are about the same. We don't have to worry about strip heat. We can use a heat pump. This one definitely can go without a heat pump. And
Yeah.
this is, by the way, this is two different zones. This is first floor, second floor, all grouped into one. This is the entire house, so the loads are
Mhm.
getting smaller when you split them up even into two.
And I really like this too because oftentimes this is not a part of your heat load calc, right? It's
Right.
often a just sort of like check the box of how tight it is and move on.
Mhm.
No one
Right.
has the conversation of what does it change of your load if we change the air leakage, if you're even going to do
Exactly
a
right.
blower door test to ever even know. So I
Yeah.
really appreciate that context. So
Yeah, and I think I want this slide to help people understand, like people ask a lot, like what's the most cost-effective way to, get to a high performance home? You obviously want to protect, have your water control layers. That you want to keep the water out of the building. That's
yeah.
number one. And that's stuff you do normal. The code requires it. Everybody requires a non-leaky, no water in the house, right? So the air sealing, put all of your money into your extra money into air sealing, if that's what you want to call it. But the most I've seen spent on making a house go from 5 ACH 50 to 1 AC or to below 1 ACH 50 is about a 1% of the construction budget. That builder went through about 1,000 tubes of caulk. This was about 15 years ago. And we didn't have what we have today, obviously, but he just went through every single rafter around with the caulk, every single rafter, and just air sealed the whole thing. And he got down well below 1 ACH 50. And other than that was a bunch of labor. But everything that we're doing is just stuff you would normally do. You pay a little more attention as you go. You're not going to spend even 1% for the extra, but put everything into air sealing, normal insulation, decent windows, all that's fine. Get your air sealing done because it just dramatically cuts your load. And that's where all the issues are, right? All right, so get more specific with the the house, 2-story, like I said, Craftsman. Um, we are going to use heavy timber, so it's going to be using classical details, Craftsman details, and these are UPVC windows that we're getting from Poland and France, and everything is custom made for it. And these are 4x8 rafter tails and 4x4 brackets, and we're going to have a lot of fun with the craftsmanship on this one. Again, 2-story, most public spaces. This is the kitchen here in the middle. We're doing kind of that not open but connected design. I feel like open floor plans are starting to be less desirable these days. I don't like them. Anyway, we do have a sauna. This is more interesting for like the passive house and how much energy are you using, but we have a sauna and a cold plunge in here, which made getting FIA certification a little more difficult. But a couple of bedrooms downstairs, upstairs, all the rest of the bedrooms, master suite. So that's the design. So getting just getting a little science, building sciencey here. Second law thermodynamics says you got a high pressure and a low pressure. They're always going to go from that high to low or hot to cold. Think of it as like a business meeting. When there's pressure in that business meeting, you leave, you get out, you go where it's low pressure, and that's the cold, hot to cold. That's just conceptually how all this works. So here's kind of a drawing of assembly, kind of good, perfect wall, good layers. You got your bulk water, then you got your water resistant barrier, which acts as your vapor and air control. And you got thermal control layer, which is we do exterior insulation everywhere. We do at least 2 inches of stone wool, and then we fill the cavities with more blown in stone wool. Then we have the all-important vented rain screen cavity here, and then, of course, the framing. So this is sort of a conceptual, wall, perfect wall. And the important thing is make sure connect it all the way around the structure. The floor is the wall, is the roof. Looking at your building sections, draw a line, make sure that everything is continuous. No interruptions at the corners, at the penetrations. All of your water, air, vapor, and heat control layers are fully continuous, especially air barrier, as we're talking about that. We provide these sort of typical details. This is you're going to have this slide. These are just for a little bit specific to our project. But we do this, we strip all the insulation and the cladding off so people can conceptually see, the crews can conceptually see, just every corner, every transition. This is what we need to do at each one. And this is how we're achieving our air barrier. This is the floor to wall section. You guys have this detail now. You can look at it closer afterwards, but what I'm showing is that we have this beautiful continuity between the floor and the wall. This is an 8-inch slab. It's a floating raft slab. It's all 8 inches thick, no matter what. There's no turn down, there's no thickened areas, nothing in the slab, no piles. This works in climate zones where the frost line is 12 inches, and that's what we are here in Georgia. There are variations of this that will work all over the country, but you have to understand your climate. So we're able to get away with this here and a lot of the Southeast, but don't do this unless you know this will work. So we've got this, anyway, this is a thermal issue, but we've got this footing here to support our brick only, and it's not connected to the slab. So that insulation can just continue around the corner. So there's our slab. This is a little better look at it in 3D. We've got our flashing system here, brick flashing system there, and this is how the layers are going to look as we build it out. These furring strips, will hold the insulation in place, and then we'll attach all of our siding to that, to those 1x4s. This is a termite barrier here that ties into a waterproofing membrane here to prevent any moisture that gets behind this brick to get into the slab. And then we've got our vapor barrier, 2 inches of stone wool underneath the slab, and then our 8 inches of gravel and the footer. So you have this now and you can take your time. So I just want to show this one. This is super important with our, trying to get that perfect envelope. This is an example detail of, we have a screened porch on the back of the house, and this is one of the columns that supports the roof structure. And you can see here the insulation continues around the corner of the house structure. All of our layers continue around. This one screw is going to give it a little bit of stability, but it's not required for structure. This structure stands alone. There are going to be 4 columns. It'll still appear as being attached to the building. All of our cladding will just die, kind of terminate at the column like this. So it's engaged. It's an engaged column. The whole structure is engaged with the cladding layer, the outer layer, so that you still have that architecture without, penetrating our perfect layers. So we've done a lot of these. This is something that's really important when you're doing these envelopes. Here's our wall to roof transition. This is, right now what you're seeing is right at that red line. None of the insulation is in. None of this out here is in. This is a 4x8 here that we're going to cut. We're going to rip this little notch out of it here. And our insulation on the roof is 4 inches thick. So we'll notch it so we have 4 inches and it's flush. Then we run 2x4s on top of that to support a sheathing for our roof structure. So we do all that to keep it simple. This is what we're calling monopoly framing, because those little monopoly houses, some of them don't have roof overhangs. That's why we have that term. So good example here. If you guys follow us after this, we'll be posting a lot of progress on our Instagram and YouTube. Here's a 3D version of that. So you can see the layers kind of building up. And, just this 45-degree kind of supports cross ventilation. And then you have your additional layers here for the roof. This liquid applied membrane is sort of one of the keys to getting there, because we use the liquid now because it's, so this is, by the way, for anyone who's not aware, this is like a house wrap. So this is our liquid applied house wrap. So this is done in 2 coats, but every seam is sealed first. On the roof, it's not required. We do it because we want that air sealing. And then we put our underlayment over the top of that. So that acts only as an air seal. and it proved to do the trick. I've done it without it, and we got to 0.05 ACH 50. This house is 0 because I think this is one of the details that made that happen. Rolled on by our painter, and everything from concrete to, the joint between concrete and plywood, all covered up in this. This is STPE based liquid applied, and which stands for sticks to practically everything, because it does, and it moves with the building if it moves. So it's really good, and it's very forgiving for the installer. I recommend using a painter. So this is before the second coat. You can see all the light colored stuff is the reinforced, and that's where it goes over the seams and all the nail holes there. We do have windows. We're doing site-built stone wool buck. These are insulation bucks around the window, and you can see all this blocking here. That's where we'll attach. We use that to attach the window to it. These are European. They have clips. So we'll attach back here, and then exterior trim gets attached to this here. So we've got them staggered, and so we don't have any thermal bridging in this stone wool. It's a little tedious. It's a new thing. There isn't a product out there yet to use stone wool, but we're never going to use foam. It's a 4-letter word for us, and an F word, and it can kill people. I've seen people, collapse on my job site because of it, and I don't. So anyway, this was our experimentation on this first window, and now this week they're finishing up the rest. So that's our window. The other big topic was ventilation. Just pause for a minute so you can read some of these fun comments. This one in the top left, I think I've already addressed this. I said that, we've done a house at really low, really tight, and put all the penetrations in, and we ended up a little bit tighter. So it's possible. Okay, I want to get through these real quick. This is the ventilation. We do have an ERV. It's a Panasonic 200 CFM. We're going to be delivering about 140 CFM for this house. And we take these out, and these go to these little plenums here. This is a RHEIA ductwork system, RHEIA. You can go check them out there. It's like kind of like the manifold system for your plumbing. It's sort of how this works. You've got the hard duct out to here. You use a little plenum box here, distribute it with these smaller 3 and 4 inch ducts. Really great system. We'll be talking more about that, but this is what provides our fresh air for the house. This is everything. We're going to have a pre-filter on the incoming side to get the big chunks of stuff coming in, and then we'll let the filter and the ERV handle the rest. But this will be running 24/7. It handles the exhaust for the bathrooms and supply air for the house. We have a makeup air system for our range hood. Why? Because anything, especially below 3 ACH 50, you're going to start putting the house under negative pressure. You got backdrafting. You're going to have, backdrafting of gas appliances if you have them. Your other mechanical systems are going to get short-circuited because you're putting negative pressure. The short of this is it can be complicated. Fresh air is coming in. We've sealed this range hood, a chamber in this range hood, so that fresh air can come in. It's lined with either duct tape or a liquid applied membrane. It dumps into this space, but immediately gets pulled out of this by, I have the wrong section in here, but there's a 3-inch a 3-inch grill here, and the air comes down and gets picked right back up and goes right back out the vent here. So sorry, I got the wrong one here, but it will basically come down in the chamber, get sucked right back up, just like a commercial range hood. So this, and then this duct is, the incoming air needs to be sized a little bit larger than the outgoing air to make sure you have the right, that's pulling everything from fresh air. Oops.
Chris,
Go ahead. Yeah.
So go back to that slide. I think of like some codes and most of the green building programs allow you to have what we call 5 air changes per hour in the kitchen for compliance. So basically you're putting an exhaust duct or a supply duct somewhere in what we would define a kitchen. So we would, draw some kind of rectangle or triangle and do all the math. and
Yeah.
we'd say, hey, there you go, 5 air changes per hour. You got the and we don't have to have that duct going out because it's another penetration, it's another air leak.
Yeah.
Or I've seen some passive house projects, of course, directly just run the ERV through the range and straight out, and of course have some
Yeah.
kind of grease filter. I've been seeing
Mhm.
that a lot less, but I'm just curious if though either one of those approaches were considered and why you kind of went with the traditional. It's not traditional, but the range hood.
Yeah, this is the most effective way to keep things balanced, and to keep it from uh, passing over people's heads or having to cross through the rest of the house or wherever. I've seen it come from underneath so that the outside air is then blowing on your feet. Works okay in mild climates, terrible for cold climates or really hot climates, right? So
Mhm.
you have that air coming in, but it doesn't have a direct link to that. I think we didn't really consider anything else on this one because we know that this one has proven to be the most effective. And you've got, I mean, it's how you want the hood to operate anyway. You don't want to have to put that extra load on the house, right? And that's the whole point of the zero leakage is you're trying to keep all that outside air out. This one gives us a direct path for that outside air. Does that make sense?
Yeah, yeah, thanks.
Okay. Okay. This is something, this is the first time anybody's seen this other than us, but we have a 220 CFM dryer in the house. And because we have the zero leakage, we have to bring that air in and then let it exhaust out um, through the dryer. But we have to balance the house and make up for that pressure difference. So what we're doing, we have air coming in. This is all duct work, and I just drew it, and this is how they installed it. It's just it's a 8-inch pipe, two 8-inch pipes coming in, merging into a 12-inch pipe. And this is the fresh air. This is a filter here. We have a backdraft damper there. So fresh air comes in, but there's also this damper here is it engages, it opens when they start the dryer. So they're actually going to have to hit a switch. It's because nothing else is the dryers don't communicate like that yet. So we have to hit a switch. We'll open that damper, turn on the fan for the dryer to help assist to get air out to make sure it leaves. And so anyway, this is the conditioned air for the attic. It's a fully conditioned attic. It's always going to be running. When this opens, you're going to have mixing here, and we did this long dead end here so that we have lots of opportunity to pre-mix before it dumps into the attic, where we have also pre-mixed return air, no return ducts on this system. We're letting everything all the air transfer to the attic through grills, through transfer grills that have fire dampers on them. That's the code thing. So we're letting that air get into the attic, and it's all mixing. And so this will all mix before it gets to the air handlers. Uh, yeah, before it gets to the air handlers and filtered and then conditioned again. So we're using the attic as a mixing chamber. This is a smaller mixing chamber. This is a lot for a 220 CFM fan of dryer. We understand that, but there's no other way to do it. Well, there is, but we haven't come up with that yet. This one works. So
Um,
yeah, go ahead.
Chris, one of the questions was, of course, you gotta clean your dryer exhaust, dryer fires, all that. What does it look like for a system like this in the context of cleaning a dryer exhaust and the maintenance?
Same thing. Yeah, same thing. Same
Yeah.
thing. So the dryer vent, the dryer duct is going to also be run through the attic, and the attic is really clean and wide open.
Hmm.
We're gonna have storage up there, but the yeah. So the dryer has a booster fan, and it's going to have to be all of it have to be cleaned very regularly. Yeah.
Yeah. Um,
So yeah.
and one of the things we've always said, and I've personally done in two homes is, on a renovation, eliminating the dryer exhaust because that's one more hole, one more air
Yeah.
leak, one
Yeah.
more th place pests can enter. And then a new construction, just eliminating it from the
Yeah.
get-go And it's
Yeah,
interesting to see your goal is to target tightness, and yet you're adding this in when there are, of course, condensing dryers or ideally heat pump condensing dryers.
correct.
So can you speak to that a little bit about why those were just not used so you can just eliminate that hole?
Owner preference.
Yeah.
Only owner preference.
Yeah.
We actually there are two dryers in the house, and one of them is the it's the heat pump dryer,
Yeah.
and that's in the mud room. But the one upstairs in their master, right off of the master, there is going to be this. And it has to do with with timing. I mean, the
Mhm.
heat pumps take longer. The
Mhm.
dryer, this dryer, 220 CFM, it's a
Yeah.
commercial dryer, so it's going to go super quick. So it was discussed, and we spent a
Yeah.
long time on it, but there was no
Yeah.
didn't make any
Well,
sense.
it's
Yeah,
great to see that, there is a solution out there
there
for
is.
super
Yeah,
tight homes who need the old school dryers, I'll call them. So,
yeah. I
yeah.
mean, it's just like, yeah. I mean, it's the open fireplace, the open combustion fireplace, the wood fire burning fireplaces. They're the only thing left that I sort of
Yeah.
that we have to figure out, because that it gives ambiance, but you don't need that wood. You're going to be burning twigs to keep warm because of how well the house performs. So
All
get
right.
used to the Netflix fireplace, because that's what we do.
I
I
have
mean,
been I have
yeah,
been regularly using that one for several
yeah,
weeks
yeah,
now. So
exactly,
yeah.
exactly.
Yeah.
Okay, so I talked about full control. It gives me control of the air, and the goal is permanence. I want this house and the people in it to last as long as possible. I want to protect it for for the earth. I want to protect it for the owners. I mean, I'm an, we just want full control over everything. That's why we're doing this. That's why we're achieving it. So here are some tips. Yes, simple rectangular geometry. You've heard this before, like BS talks about this. Simplify your shape. Complexity in the roof. That's going to, of course, add corners and tricky spots, tricky details. Plan ahead. If you don't, I mean, draw every penetration in drawings. If you have an architect, make sure they draw all the paths for your ductwork and your penetrations so that they can plan for them, and maybe move them if they have to, but plan how much detailing they're going to have to do for air sealing. Simple transitions like our floor to wall and our wall to roof, monopoly framing, wonderful detail. And like I showed you, no structural penetrations, that we're doing. And you might ask, Craftsman, super quirky. They're not simple shapes. That's what Craftsman can do. These are recommendations up here that say, hey, if you want to have a simple form, go for it. It works. It helps. But if you have a Craftsman and it's a quirky plan, it's fine. We can still do it. Clearly, we got 0. Last little housekeeping is just make sure that everything you do, uh, if you like what you see here, if you want to try it, go for it, but don't copy paste it. Make sure you get with an architect. I can help you anywhere in the country. It's fun. We can work anywhere, but get somebody who knows, get your structural engineer involved in some of these details, just because it's important to know your climate. So that's it for me. I can't wait for some questions and some back and forth here. So Brett, I'm ready to turn it back to you.
Yeah, great. Thank you, Chris. Well, we do have some questions coming in, and we've got some more time for questions. Before we jump into them, just a real quick reminder that yes, this session is being recorded, and you can check back at our YouTube channel in the next week, and you'll see it there. Or you can go there right now, click subscribe, ring the notification bell, and you'll get an instant update when it is available. For those of you watching this in the future, not right now, but on demand, take your quiz with an 80% passing rate to receive your continuing ed certificate. And for those of you here today, as long as you've been here for the entire CEU approved hour, and you take that survey that pops up at the end, throw in your AIA number if you need it, You'll receive your certificates from certs at gutenbergcerts.com. Check your spam for that in the coming days and look for that there. And again, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, our nearly 500 members. We're trying to get there by the end of the year. And if you haven't become a member yet, please do so we can hit our goal. And all of our sponsors who allow us to do what we do and help you build better homes, more airtight homes. Panasonic, Tamarack Ventilation, Build Equinox, Timber HP for decarbonized wood fiber insulation, Rheem, and for decarbonized water heating options. Chris, one of the questions that came in uh, was maybe just clarifying your your air barrier materials. Now,
Mm,
of course, we think, we're going to see a home that's just loaded up with spray foam, and you clearly articulated that's not the case.
mhm,
But what you are using for your air barrier, what is it made out of? Is it made out of petrochemicals? We think of health, we think
mm,
of decarbonization now in our materials. How much carbon is actually going into those materials? Clearly, spray foam high on the chart. For both those issues, you've eliminated that.
sure.
But someone else here still said, "Hey, I'm concerned, and I don't know if I can take what you're doing seriously. What is this stuff made out of?"
Mhm. It's a chemical. I mean,
Yeah.
just like a lot of things in our buildings are chemical, and that you pick your path, you pick your what you're going, like our goal, of course, tightness is one of them, right? It's
Mhm.
just one. Everything is made with some sort of chemical in there. This stuff is STPE, does stand for something other than sticks to practically everything. It is a chemical, but the chemical allows you to stick. It has, I think the threshold in most like LEED and other programs is 50 grams per liter. And this stuff has about 17. And
Mhm.
it's again on the outside. And not that I'm ready to dismiss any off-gassing. Oh, who cares? It's going to go up to the sky and not bother the people.
Right.
I am concerned about that. So if I'm going to use something, I do think about it. I don't just say, let's just use lacquer on everything. Let's just
Right.
make it a toxic environment. So no, it's not going to kill anybody unless you drink it, extensively. I mean, it doesn't smell. When you put it on, there's no fume there's not vapor coming from it. It's very low toxicity
Yeah.
for a product like this, but it is a chemical. And so, yeah, you got to be careful. Should we wear masks all the time? Yes, because
Mhm.
there's stuff in everything, you know?
Yeah. Um, and then following up, when you're making homes super tight, of course, the threat now of air quality starts to come from the inside.
Correct.
Now, of course, you have your ventilation systems in place. You're probably, hitting your targets, I'd assume, for ASHRAE
Mhm.
62.2 and all that. But what are you working with folks to sort of make selections for the materials actually going inside to reduce,
Mhm.
issues from an airtight home?
Sure. Durable ones. We're using real oak
Mhm.
floors, not anything, no laminates or anything like that. So
Mhm.
solid oak finishes. We're doing plaster on the walls,
Mhm.
to help with the air quality, but also it's beautiful texture. And
Mhm.
it's a Craftsman. It's what belongs in a Craftsman.
Yeah.
And then we do have like the drywall choice mold guard. It's not just just any old mold guard. They're very specific performance requirements for that drywall so because the making of it. And so we're using the GP mold guard, Georgia Pacific. So and we're not going to have any paints because I mean trim will be painted, but it'll painted off site, and we're going to have our plaster, which doesn't no toxic. But it's and then cabinetry, using doing
Mhm.
our best. We still want something quality. We're not going to, we need to make sure everything's going to last. And yeah, we can look at all of that. It's so difficult, as you know, Brett. I mean, doing this sustainable thing the old green approach of trying to chase all of these VOCs like that. It's
Mm.
manufacturers are just making them better over time. And so things are getting lower and lower. And now our thresholds, and so there's so much more to choose from
Yeah.
that makes it less toxic in there. And we're not using any, man-made, we're avoiding the man-made stuff that's full of chemicals,
Yeah.
natural
Um,
woods and things.
was there any considerations for your project to do the sort of automatic blown in stuff where you can just hit whatever ACH target you need by blowing in the sealant? Is that something you've used or looked
Oh,
into?
the aero barrier? Is
Sure.
that what, I mean, one of
Yeah.
those. Yeah, yeah.
Yeah, yeah, yeah.
I don't, I have not ever used that. I only see that as a value in existing homes that you cannot
Huh?
take the exterior off, because the reason I don't ever use it on a new construction is the right place to do air sealing is on the outside, always, because you want to keep the outside from touching your sheathing. That's the one of the most important things, because that's where the problems happen the most.
Right.
So you stop it at the face of the sheathing before it ever touches the structure. The aero barrier, like I said, is a good backup in an existing home when you have no access to the exterior. You can't,
Right.
they're not paying to remove the siding, let's say, right?
Yeah.
And the sheathing is intact. Let's just go ahead and do that. I wouldn't do it on any house with no sheathing. I wouldn't do it on, things like that. So it's a very careful thing. And I'll use it in the ductwork, I'll seal it that way. But I don't trust
Yeah.
it as a long-term solution because of, well, this is a whole
Yeah.
debate, but it's just if there's a tiny crack and it fills it, the
Yeah.
building moves, that tiny crack opens up because it's not a lot of goop, not a lot of stuff in there.
Yeah.
I don't know. This is long-term stuff. We don't know yet.
Yeah.
It's got to be around for another 30 years before we know.
Yeah. There's a question here about radon considerations. Now, I know first of all, people look at radon depending on the zone or the code, and I would argue that should be immaterial. We have to look at it everywhere because it can happen anywhere. And of course, we see there's some data coming in that when you have good ventilation, it suppresses it. And I saw on your plans there, you had the sort of the sort of passive approach in the slab to dealing with it. But the question here was if you had an active fan, and I don't know if you did, I couldn't remember, but they were asking how you handle the makeup air from that if it's running all the time, or are you just not doing that?
No, that's a good question, but it's not connected to the inside. I mean,
Um,
it goes under that vapor barrier, which is also a radon. They're calling it a radon barrier. It shows that it can actually stop some radon. I don't know how much, if it's
right,
fully, but it's rated to stop all of it. But
right.
it, but it, so that is taped to that footing that's under our brick. And so it's sealed off from the house that way. So it's totally, and so anything that's underneath, it will find its way. It's such a very low pressure. They used a 3-inch pipe on this project. Usually it's 4, but because it's so efficient now that it's going to just it's going to pull out, and it's going to pull from below that vapor barrier, right? So it's not going to, we've already tested it. It's not pulling from the house. We've run a pressure test on it. Yeah.
Yeah. Um, so of course the question always is, with these kinds of things, like, what does this cost, right? And
Mhm.
and and of
Yeah.
course there's always that, here's code. So then of course the question has to be, what does it cost more than code? And what is the code? Because there's very different codes
Yeah.
all over the country. California is a very different world than somewhere in the middle of the country who probably has no code, or some
Yeah. 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 Yeah.
lacking code. And so you have different starting lines, and we're talking to everyone here all around the world. So
Sure.
just in that context, can you speak to, the sort of cost question?
Yeah. Yeah, it costs. It definitely does. So I use an analogy that I like. It's like if you have a need for a garage on a house, right? You need to park your car, you need to store things. That is a necessity for you. It costs more money. It takes a certain amount of money. I shouldn't say more. It takes a certain amount of money to get that. You could have just the house and park your car on the side of the house. But if you need that garage, you're going to spend the money on that because that's valuable to you. So that's it. I see what we're doing. There's no added cost for what we're doing. It is more to achieve the code. That's a code built house and a tight house, these tight measures. It depends on what you're using. In our case, it was super valuable to get to this air change, to get it under control. And to do that, we used methods and materials that help us achieve it. That's a long way to say that it's all about value and not cost here, because this is valuable to the homeowner, to the project. So we spend the money to get that. And we're not comparing it to zip system or house wrap or anything like that, because we say, look, this is what we need to do. We know that those two can't do it, so we have to go with this over here. Did we compare it? No. But I think it's all relative to, does it cost more than zip system? Yeah, probably. But if you do zip system perfectly, with all the liquid flashing and everything else, could be the same. It's so difficult to really throw any kind of yes or no, more or less kind of thing on that. It's just about the value and what it means to you. And getting air sealing doesn't have to be liquid applied, but all these other things we're doing are just framing. I mean, the monopoly framing, it's not a big deal, so just getting these details right it's valuable,
Mm-hmm. And the other question that came is, can you talk about monopoly builds versus vented attics and any other build strategy to achieve zero or near zero air leakage?
Well, so whether you have a vented attic or a non-vented attic, or over framed, over ventilated, whatever, it's getting the air sealing details isn't impacted by which of those attics. But if you don't want to say you don't want to go to the roof line with your attic or with your insulation, your control layers, totally legit. I love it. I have a detail. If you all check out the Instagram page, I think today I posted one where it's the attic. We put sheathing on top of the ceiling joists, and then we filled up with fluffy stuff up there. All the mechanicals are still inside. There's no access to the attic other than for emergencies, but it's not for storage. So we just put the sheeting on top of the ceiling joist, air sealed that, connected that layer, that zip system, to the wall zip system, and then we created this perfect square, this perfect cube. Insulation all went to the outside. We did like 18 to 20 inches up there, and then the wall insulation on the outside. So that one is a very, very efficient setup. It's in North Carolina. Their average bill for 3,000 square feet is about $50 for all utilities. And they have a gas fireplace. Guess what? They don't use it, and the only time they have to open windows for it to be cool enough to use their fireplace. We told them not to, but they did it anyway. So, they were like, we have to have the fire, we have to have it. Okay. So anyway, so I think the vented over roof, going to the roof line, it's really the best way to build right now, based on what we know. So if you can do this, what we're doing here, it's just, and then you can condition the attic so you don't have any, you can control the moisture that it's in that attic and what's happening on the assembly. So it's, because the one thing, I think Joe's saying this now, Joe Stiebrick of Building Science Corporation, he's saying that wood can see moisture. So if we are letting that moisture go into our attics and vent through the roof line, all the way as it's going up to that roof line, it's seeing all that moisture in the air. It's being exposed to it. So let's get it inside, just like I do on trying to get all the structure inside. It's not always possible, but that's a really good way to build. Yeah.
Yeah. The other question that was if said if you didn't use PolyGuard, would you instead use Siga SA or Intella Add Hero 3000 of plywood instead?
Yeah, they're the I like the roll products. I think when they're in, just like anything, when it's installed properly, I'm a
Hmm.
fan of it if it works, other than foam. Um, the roll products, I haven't used them because the cost to do that versus this liquid, there wasn't a difference there. Like doing because the to do that liquid or the self-adhered properly still requires getting some liquid in there in some of the gaps because I don't trust to try to roll that perfectly and get all those seams out. You could do it. It takes more time and effort, but guess what? The liquid is less forgiving or more forgiving, excuse me. It's
Hmm.
more forgiving because you can get it basically on the first shot. There's no spreading, there's no did I miss a bubble? You have to make sure you get good coverage and you get everywhere, right? With the liquid. But that's a little easier to do than to find. Anyway, it's all about means and methods. They're great products.
Hmm.
They're awesome. Do it if that's your preference. Just do it right. Just follow the
Hmm.
instructions and
Hmm.
you'll get there. Yeah.
Yeah. Um, Another question came in. Did you or would you consider using advanced tech on your external walls or roof instead of plywood if you're not able to cover your plywood within 3 months?
I'd consider it, sure. Sure. If you got to look at your schedule, the schedule of the project and see
Yeah.
what makes sense if you can't cover it. But yeah, I mean, we obviously in our case, we once we got the sheathing on, that was our trigger to put the liquid applied on. There was nothing else we needed to do before we put that on, and the roofing underlayment. So, but yeah, I mean, Advantech is they I don't know that I mean, I think Zip system it lasts a really long time as well. It has a good outdoor rating. So yeah,
Mhm.
what the goal, it's not about the product. It's necessarily a certain brand, but it is about, let's see, what is our goal? And like, what are we trying to do? Like insulation. I only use stone wool because what are we trying to do? Insulate, keep the bugs out, um, keep fire out, keep moisture. I mean, all of the things that we're trying to do with our building products, insulation does a lot. This stone wool does a lot of that all in one. And so I don't have to think about it. Can the termites burrow? Mm, No, not really. They don't eat this stuff. So anyway, it's all choice based on problem solving. What is it that we need to solve with that assembly? And if it means Advantech, sure, I'll use it. Yeah.
Um, Another question came in about your under slab stone wall application and
Mhm.
as to whether there are structural limitations on that, for example, like a two-story home.
Right. Definitely. The stone wool we use is a Rockwool Top Rock DD. You can go look that one up, and it gives you the PSI ratings on there.
Mhm.
And we had to kind of go to that density because the Comfort Board 80 from Rockwool or Comfort Board 110 doesn't have the capacity, that the Top Rock does. It's more of a roofing product. So we use that under there. There's also Powerwool, um, uh, Board Pro
Yeah.
Max is even denser than that. And so that one, so anyway, it's all about that density. We hand that over to the structural engineer. He does his calculations. He says whether if it's enough or not.
Yeah.
And if it wasn't, we would have gone to another product.
Yeah.
But that we wanted to maintain that flat 8-inch slab.
Okay. You mentioned passive house training and all that, and clearly
Yep.
you're exceeding passive house air leakage targets.
Yeah.
Are you typically getting fully certified to that program with your projects?
This is going to be the first certified passive house in Georgia,
Oh,
probably in most of the southeastern states.
wow.
We're working on another one right now as the consultant in Chattanooga, and it's the first one in Tennessee. So the Southeast is
Yeah.
pretty limited in terms of passive house. So
Sure.
yeah, we had one other project that got design certified but never got finished. So
Right.
we don't know, but yeah. So this is a new thing for the Southeast. We're going to be
Yeah.
presenting at FIASCon next year about this
Yeah.
project. Yeah.
Yeah. Well, so partially the reason I asked is, a question in here talked about basically resiliency during grid outage. Now, it was really interesting for you to show the sort of contrast of your increasing heating and cooling load and decreasing cooling load
Hmm.
for your home because I think of passive house resiliency. I think, okay, that's going to keep the extreme weather out. But I
Hmm.
didn't really think about it in the context like, wow, it seems like we're almost in a better position having an extreme winter, keeping
Hmm.
that out versus the flip side of the summer when you have these higher cooling loads,
Hmm.
versus heating loads. But anyway, so the question was just
Yeah.
like,
Yeah.
what are you doing about backup? Clearly, passive house is an answer, right? That's an answer, right? But anything
Hmm.
else in what you do as far as, protection against grid outages?
Uh, Operable windows.
Yeah.
I mean, it's the only thing you can do, right? I mean, or a generator or, something or solar backup batteries or whatever. None of
Mhm.
that's being planned for this. In a
Okay.
typical situation without backup power or anything like
Yeah.
that, I mean, you just go old school ventilation, right? You
Yeah.
have to. Um, the house is going to be okay for a little while. Like if you're in the house and you don't have the fresh air coming in or out, it's going to
Yeah.
be, depending on the outage, what's going to happen even in 4 hours.
Yeah.
As long as you're not using, you can't use anything else like the
Mm.
range or whatever, so you're stuck. And so you
Yeah.
just stay still and wait, but open a window,
Yeah.
like one window, and even on the hottest day in summer, yeah, it'll get a little uncomfortable, but do it on a north facing wall, so you
Mhm.
don't have the direct heat.
Yeah. And I do think about I've been in some of these passive house projects before the ventilation has been installed and filmed in them, and it's just been like unbearable. And I think about,
Hmm.
yeah, that in the
Yeah.
context of that or worker protections, in these super tight homes and is that coming to thought because there's just no air moving.
Hmm. Oh yeah, yeah. Right before we did the blower door test on this thing, the mechanical contractors started their rough in. They were putting equipment in up in the attic and everything,
Yeah.
and they had to. They were like right after we did the blower door test, they were just like begging us, "Can we cut a hole in this house?" When you went up to the attic,
Yeah.
it was the most bizarre feeling I've ever experienced inside a building, but it
Uh,
was just it was beyond stagnant. It was like this, there was something like this, it felt like a physical pressure.
right.
It was something else.
I,
And
I
so,
I I know the
yeah.
feeling. It's like a ghost
Yeah.
in your brain and in
It's,
your lungs haunting
yeah,
you.
yeah, yeah. It's pretty wild. Yeah. Yeah,
Yeah.
for sure.
Yeah, Chris. Well, I know we're at our time, and I really appreciate you
Yeah.
coming out and doing this and having you back on the show.
Yeah, it's
Um,
fun.
can you just remind people where again they can, reach out, learn more? I know I follow you on LinkedIn and I love it, and that's
Yeah.
how I learned
Yeah.
about this. And so I,
Yeah.
I certainly encourage people to connect with you there, but anywhere else?
I spend a lot of time on Instagram right now, and
Yep.
YouTube's going to be picking back up here shortly. Those are the two social media platforms. Our website, lgsquaredinc.com, is a great way, and I put my email on the presentation,
Yep.
and you can always email me there, and love to chat with anybody. Yeah,
Yeah. Yeah. All
yeah,
right. Well, Chris, thank you again so much. Take care, be well, and we'll see the rest of you all next week. So
yeah.
goodbye.
Thanks, everybody.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.